Welcome to methamphetamine. Today we're gonna do the integral of psi x over x going from 0 to infinity. And this is a really famous integral question. And here's the deal. We're gonna do it in two ways. First, I'm going to use the Feynman technique. It will be way harder than the other one. And then the second method is to use the special function. And first, we're gonna do the integral of psi x over x. How to integrate psi x over x though? And if we only focus in the elementary functions, we cannot use the SI function because the integral of psi x over x is just equal to SI of x. That's a special function. You can check the definition of SI of x on the internet. So here, to use the Feynman technique, because this integral cannot be integrated, right? In our elementary way, psi x over x. So to use our Feynman technique, and how can we use the Feynman technique? I'm going to teach you that our I of, let me just choose f here, because Feynman technique, right? So I'm going to use f as a variable. You can choose many variables here, but don't choose e and I, because e and I just mean other thing, right? So I of f, you see the integral of psi x over x. It will be way better if we don't have this x here, because if we don't have the x here, it will be way easy to integrate, right? Way easier to integrate. But we're gonna multiply some function. So first, I'm going to try psi of ax over, which is f as our variable. So we should use f here. Psi of fx over x, because if we differentiate both sides with respect to f, you pretty much 1 over x is a constant in the f world. You can stay the same, and then you will get differentiate sine of fx, you can get cosine of fx. But don't forget to multiply by the derivative of inside because of the chain rule. And then because we are in the f world now, x is just a constant, so over you just get multiply by x, and then that x and x that cancel each other. So let me just differentiate both sides. So let me try to use this as a function, okay? So differentiate both sides with respect to f. So differentiate both sides, be sure you need to use the partial derivative. So I'm going to show you some steps because I'm going to teach you how to use the Feynman technique this video. So the partial derivative symbol is like this, and then it should be respect to f like that. So the integral of psi of fx over x dx like that. So over you can bring this derivative inside the integral. So let me just do it really quick. So 1 over x stay the same because it's a constant in the f world. And then differentiate cosine, right? Differentiate sine, you get cosine. And then multiply by the derivative of f of x. In the f world, you get x. So over, you pretty much just get this. The integral of cosine of fx dx going from 0 to infinity. However though, cosine of f of x going from 0 to infinity. And then here's the deal. Cosine, the graph look like this, right? Going from 0 to infinity. And the infinity, I'm not sure what infinity, how long is the infinity, right? So the area cannot be defined. This integral will not be convergence at all. So we can call this integral is divergence. So over, we can choose put a function inside sine of f of x over x. So don't do that. So far, we have to choose another function here. So over this integral is divergence, so we cannot choose this, right? So we're gonna use another variable like that. So over, we let r of f is equal to, how to cancel out the x? Let me think about some function that we can cancel out the x. So first, I'm going to choose ln of f of x, but n of f of x is not a good thing because we're gonna have, after we integrate it, even let me consider this function can be integrated. However, though, you're gonna figure out what's the constant. We're gonna figure out what's the constant at the end, because you get I prime of f is equal to something, and then we're gonna differentiate both sides once again to get back to our I of f. However, when we integrate both sides, this you get some function plus some constant here, and to figure out this constant, because that result is pretty much just I of f. So far, if we plus 0 or 1, we cannot integrate sine x over x times ln x, right? And this is really difficult. And put 0 into it just diverges. ln of 0 pretty much just undefined. ln 0 is equal to, ln 0 is just undefined. We cannot choose 0. So we multiply by ln of something because we're gonna differentiate both sides to cancel the x. But however, though, also one thing, sine x times ln of x, sine x of ln of something times can be integrated though. No, sine x times ln of x is really just non-elementary integrals. So the final thing we're gonna do, what function can we multiply by and then produce the extra x? So I'm going to do e to the power of negative f of x like that. Because when we differentiate both sides, you pretty much just get e to the power of negative f of x, and then differentiate and then multiply by negative x at the end, because negative x is just a constant in the f world after we differentiate both sides. Be sure you need to put a negative sign because we consider f is greater than 0 or equal to 0. Always, we don't want f is due to a negative number. So f should be greater than 0 or f is greater or equal to 0. And sometimes we choose f is greater than 0, just greater than 0, because some function, we're gonna use the Feynman technique. If f is equal to 0, that function will be divergent. So this time we're gonna let f is greater than 0 here, because when f is smaller than 0, we don't just get sine x over x multiplied by e power of a passing number, right? So it will be divergence. So make sure f should be greater or equal to 0. So far, this function will be convergence. So here, we're gonna differentiate both sides. Let me just skip this step. Sin x over x is just a constant, stay the same, and then multiply by the first you're gonna stay the same, e power of negative f of x, and then multiply by negative x. So over you pretty much just multiply by negative x here. Put the negative 1 outside the integral, and then you will see. Let me just write clearly the negative sign, negative of f of x. So far you get x and x that cancelled it. So far you get integral. We have a negative. Don't switch the sign because going from 0 to infinity, and this is really beautiful enough. And don't switch the sign, it will be really ugly. Going from infinity to 0, just don't do that. Stay the infinity, say the negative sign here. But we can also just bring the negative sign here. Let me just bring the negative sign here. This doesn't matter at all. And then negative times e power of negative f of x times psi x dx. And the fun thing is that e power of negative of, because consider f is greater than 0, and then e power of that, it will be converges. This entire function just converges. So e power of negative x times psi x, it can be integrated, right? So it will be kind of tough. Here I'm going to write down the integral to here because we're gonna use the repeating situation, because e power of something times psi x is a repeating situation. So let me just do this to here. So we're gonna use the DI method, integration by part. Put down 3, put more, plus minus plus if you like, but I'm going to put down 3 sides to here because when this is row 3, and you pretty much just get a psi x back. So let me just differentiate negative e power of negative f of x, and then integrate sides. It doesn't really matter at all if we put a negative sign here, and then it really doesn't matter if you integrate sides and then differentiate this. We have many ways. Just differentiate this, you get negative. You pretty much just get e power of negative f of x, and then in our x row, f is just a constant, and then multiply by negative f, you get positive f here, and then do it once again, you get negative f squared times e power of negative f x, and then integrate sides, you get negative cosine. Integrate once again, you get negative sines. So overall, you pretty much, since we don't have enough space, so I'm going to put an equal sign here. So negative times negative, you get e power of negative f of x, not f of x, just fx. I don't think f is a great variable because I like to read this as f of x. Always read this as f of x. So over negative times negative is positive. Multiply by cosine, and then this time that you get negative f times e power of negative fx times x. So for this time this you get positive, and then add f squared times the integral of e power of negative fx times x dx. But we're gonna evaluating from 0 to infinity. Don't forget. I forget this thing, sorry. So don't forget to integrate this as well. So overall, this is a repeating situation in our integration by part. Put this on the left hand side, you pretty much just get 1 minus that, right? So you pretty much just get 1 minus f squared times the integral of this. But in front we have a negative. This is not good at all. You pretty much just get negative times negative. Let me just factor out the negative side. Put a negative, and then you pretty much just get 1 plus f squared. Then we have a negative sign here. This is so ugly. Sorry. Negative times 1 plus f squared. And then since we put the negative side outside, so over just this. This is equal to, here's the deal. Cosine of x is always gonna be between negative 1 to 1. So for this, consider this 1, and then e power of negative infinity. And then consider this on the denominator, cosine x over e power of f of fx. And then e power of something times x, we consider f is greater than 0. So this will increasing, right? E power of f of x is way greater than cosine x. So over, consider this small number divided by infinity. So over you get 0. Here, 0, and then you're gonna subtract, put 0 to it. Cosine 0 is 1, and then e power of 0 is what? 1. 1 stay the same. So minus 1, so 1 like that. So here is the deal. If we another f and cosine and sine, they are really the same way. Because sine x and cosine, the result is always gonna between -1 to 1. So far, just cos x is pretty much just sine. So far, you just get 0 minus 0 and then plus 0 into it. So far, entire just get 0 thanks to this sinx. Be sure you need to put a 0 to this x and not the f. Be sure. So far, you just subtract 0 words. Since we put a negative sign outside, like that. Just consider this. So over negative divided by both hand side, you get the integral of e power of negative fx times sine x dx is equal to divided by negative, and then since both sides we have a negative, just cancel out the negative and then divided by 1 plus f squared on both sides, you get this is equal to 1 over 1 plus f squared. So over, since this what's that called? This is definite integral. So over just another plus c. So 1 over 1 plus f squared. It's like the Laplace transform. So because some function times e power of negative something, but we have an f here, so that's kind of different. But this integral can solve by using the Laplace transform as well. Just do the same step like this. Use the integration by part. So far, you get I prime of f is equal to 1 over 1 plus f squared. Don't need a plus d plus c. So over, you get I prime of f is equal to 1 over 1 plus f squared. So we can integrate both sides right now. Integrate both sides with respect to f. Let me use the applied symbol. So you get I of f is equal to what? The integrate 1 over 1 plus f squared in our f world. This is just inverse tangent, right? Inverse tangent of f. However, though, we're gonna plus c here right now because this indefinite integral this time integrate both sides, and then we don't have any number, so over you pretty much just get this indefinite integral. So over you get inverse tangent of f plus c. So over I of f is due to that. So over they are equal to each other. So over, let me just write here. I of f is due to inverse tangent of f plus c. So over, since we know this is due to that, so over this is due to sine x over x times e power of negative fx dx. They are equal to each other. So I'm going to figure out what's the c here, so we can figure out what's I of f. We're gonna plus some number to here. I of f. So over, if we plus 0, and this original integral is equal to I of 0. I of 0, because we let I of f is equal to this function. If you plus 0 into it, you get e power of negative 0. It's just e power of 0, you get 1. So 1 multiplied by this is just the original function. So this is equal to I of 0. So we can just plus 0 into our f because this is just our original, right? Plus c 0 into it, you get inverse tangent of 0 is 0 to 0, and the c is equal to the original integral. But this is our original integral. We don't know what's our c as well, right? So here's the deal. What if we choose 1? It still cannot be integrated. Sine x times e power of negative x divided by x. So over, since we let f is greater or equal to 0, just e power of something e power of negative what will give you 0. Yes, we're gonna let f is approaching to infinity. Let me just do it right now. Let f is going to infinity. We don't use 0. We don't use equal sign because infinity is not a number. So use this going side. Just f is going to infinity like that. So over you get inverse tangent of infinity plus c, and then this entire is just equal to 0 thanks to e power of negative infinity. This is 0, and the 0 times that size over x, you pretty much just get 0. So for inverse tangent of infinity, this is really famous, pi over 2 plus c is equal to 0 because 0 it doesn't have the area. It doesn't really matter if you're going from negative infinity to infinity, 0 to infinity, and then negative 1 to 0. They are all equal to 0 in this point. So over minus pi over 2 on both sides, you get c is equal to what? Negative pi over 2. And this is really easy. Really cool, not easy. So over, let me just erase this. We can figure out I of f is equal to inverse tangent of our f. We don't need a parentheses here since we only have one variable here. I don't think we need a parentheses. It's okay though if we put them a parentheses or not. So our c is just equal to negative pi over 2 like that. So over we original we know that is equal to I of 0, right? As I mentioned before. And then so for this integral, original integral, we can do this right now. This is equal to I of 0 like that. You don't need to write down I of 0, that's okay. And this is just equal to inverse tangent of what? This is just 0 minus pi over 2, and this is equal to negative pi over 2. Wait a minute. I think I did something wrong here. Ish. I think we should have a negative sign. I might do something wrong here. Please forgive me. We should have a negative sign here. So I might do something wrong here. I'm sorry. So we should have a negative sign here. If we integrate, you get negative 1 over 1 plus f squared. Sorry, I make some mistake. So negative inverse tangent, and then r of f is equal to negative, negative, and negative. So far, our c is just equal to pi over 2. Because this result is equal to pi over 2. Really famous result. So far, you get this is just plus pi over 2 plus pi over 2. So far, you get this result is equal to pi over 2 like that. This is really cool. This method is so hard. The second method is way easier. Way more easier. As I mentioned before, we can use the special function here. It's a special function. This is, if you integrate sin of x, this is equal to si, right? Si of x. We're gonna evaluating from 0 to infinity, and the si of infinity, you can check the definition of si of x, the graph of si of x. Si of infinity is going to pi over 2 like that. This is pi over 2, and then si of 0, you get 0. So over subtract 0, so over you just get pi over 2. So that's really cool, huh? And that's it. I think this video is not enough, so let me just stop it right here. I just do it in 1 minute, or just in 30 minutes. Yes. If you use special function,